Pre-calculus students. Gotta get this out of my way and get this out of my way. There we go. And we are on week 28. We're looking at polar coordinates and our Cartesian coordinates, right? And also complex plane, and then how we can do some really kind of cool graphing of circles and roses. And so we're a little bit reviewing what you've worked on, and we're looking at what we're going to keep going with. So my joke of the polar bear and the Cartesian bear is a memory, and here we are, a little trick here. And I said, I don't think this is what the professor meant by polar coordinates. Igloos make a lot more sense in spherical coordinates though, right? So we're playing around with these this week. Let's just look real quick at our course schedule. So we are at the end of week 28, right? So you've been working on these polar functions, so circles and roses, and so that's what we're going to review this week. Week 29 next week. We're going to continue looking at polar coordinates, kind of putting it all together, and then we have to get to rates of change in polar coordinates. We'll review that in week 29. And then week 30, you're really wrapping up the course, right? This finishes units 3. You'll do a review for the progress check part B, and then you're going to have an assessment that covers all. And then in our last 2 weeks of course, we'll do exam preparation. So let's look at this. Let's practice. So what you're going to do in this video lesson is make sure that you are first practicing the questions. You can stop the video for as long as you need to, and then come back and show that you're checking your answers. So maybe you do this in 2 different colors. So you write down what you're doing in one color, and then you check in a different color. All right, so just as kind of a review here of polar coordinates, right? We can take this polar plane and place it onto a rectangular Cartesian plane, as we can also call it. It's important to just keep in mind what's happening here. In our rectangular coordinates, we're looking at x and y. In a polar coordinates, we're looking at the radius, right? So this distance here and the angle, so the angle here, right? So this is what we're really looking at. So we have r, we have the angle, and remember the x value, because it would be the adjacent, right? The x value is r times the cosine. All right, so that's where these 2 formulas go. If we want to go from rectangular to rectangular to polar, we have r equals the square root of x squared plus y squared. You know this. This is the Pythagorean theorem, right? And when we're solving for the hypotenuse, and theta is going to be the inverse tangent of y over x, right? Because when we're trying to find the angle, we have y and the x value. Just remember your triangles here. And if we want to go the other way, if we want to reverse backwards, we have x equals r cosine of theta and y equals r sine of theta. And this should feel very comfortable because of what you did with the unit circle. So these should be fairly clear. Let's see how they're used. So you have 1, so plot both point on both coordinate systems and then convert between the 2. So on here, you are given r and theta, and here you're given x and y. So here you're converting to the rectangular coordinate system, and here you're converting to polar. So go ahead and pause the video and work it out. And then when you're ready, restart the video and check your answers. So I'm going to check answers now with you, right? For here, right, x is 5 times the cosine of 5 pi over 6. You're using your unit circle. Again, we talked about why we need to memorize the unit circle so that this calculation is easy. And then y equals 5 sine of 5 pi over 6, and you can check your work. If I'm going the other direction, right, I first have to find r, and then I can use the tangent to find theta. And I just need to be careful about where this point is located. It really helps to put it here to understand, just to remember tangent inverse, right? Where is it giving you the value and where do you want to be, right, in terms of -1. So be very careful here with your calculator. What is your calculator getting you, and where do you need to be which quadrant do you need to be to find that? All right, then we have does each polar coordinate have only one way to name it, right? So if I'm on the polar plane and I have this point out here, so I have some r, 1, 2, 3 is easily r, and then I have an angle. Well, wait a second here. I could have this angle, I could have this angle, I could have a positive r, a negative. So just remember with these, you can go ahead and try, actually see, can you find 4 ways to name that point? So first try it as a good review of what you learned this week. And then when you're ready, just restart the video and you can check, do I have it, right? So I can go -3, right? If I first go -3, and then I can go 2 pi over 3. I could go, because -3 would be going backwards from it. So if I go -3, right, and then I'm coming 2 pi over 3. So you have to be very careful of how you're working these, right? So I have 3, 5 pi over 3, right, because there's my angle right there. I can see it. It's nicely labeled. I can go 3 negative pi over 3 because I could go this way, right? So I could go all the way around. I could go down, right, to negative pi over 3. I could go negative 2 pi over 3, right? So 2 pi over 3 is opposite, right? So if I first go to -3, I go here and then I go to 2 pi, sorry, I go here and then here, right? Or I can go -3 and go 4 pi over 3 because I would be going back this direction. Right, so these are tricky, and you can see that the multiple choice answers, you could have different ones that you have to work out. On the complex number plane, right, if we add one extra, so we're not just in the, it looks just like the Cartesian plane, but now we have imaginary and real. This is pretty easy to read it. Z is the distance, so Z is the distance here, which is r on the complex plane, but I can read these very easily. I'm over 3 and I'm up +4. If I'm down here in this quadrant, I'm at -4 and then -3. All right, so we really do a lot with the same thing with the complex plane. And you should have seen this in the lessons for this week. All right, so something for you to kind of explore with. What I want you to do is I want you to go to Desmos. Let's do part of this first together. So if I go to Desmos, and I can see over here on the little tool that I can change this to be polar coordinates. All right, so we want to change first to polar coordinates. That's our first direction here. And the second part is I want to put in r equals b sine, oh, we should talk about this for real quick. When we're doing polar graphs, we have r equals the function. And it's really important to see that our input is the angle and our output is r. So just be careful with that, but we can try these. So let's do over here in Desmos, thank you. Right, we're working with r equals n sine of, I need a variable here. You're gonna let me, let's see here. I want to get my variable of theta. Here we go, I have theta, and I can say all if I want to, and then you can see what happens. So what I want you to do is see what happens as the values of b and n change. All right, and I want you to do that for r equals b n sine of theta and r equals b cosine n of theta, right? So find the equations for circles. So a circle, right? When does a circle open sideways, up or down? What is the equation for a rose? So we're looking at rose curves, 2 of them, right? So what you're doing is, how do I create a rose curve that starts on the polar axis like this one? How do I create an odd number of petals versus an even number of petals? So just play around with this and make sure you see the patterns. For right now, we're doing circle, and rose curves. We're going to do the other ones next week. All right, so I hope that you see if theta equals just a value, you end up with a line. That's kind of the easiest of these. We don't see it very often, but whatever the angle is, so here's the polar axis, this is the angle, and I end up with a line. All right, circles, right? When do I get a circle, right? So I have opens when I have positive and negative opens left. So we're looking just at the value of I. When it's a cosine A, cosine of theta, I have a circling open this way or this way. When I have A sine of theta, I have a circle this way or this way. So make sure that you can pick up the pattern on circles. It's pretty easy. All right, roses are a little bit more complicated. All right, when we have cosine, so first we're comparing cosine versus sine, but when I'm first just looking at cosine, n is the number of petals. So because this is a 3, I have 3 petals, right? It repeats every pi, right? So every time we go from 0 to pi in terms of what our theta is, we're going to have this repeating itself. We have the value of n being odd. We can kind of see that it's opening, right? The first one is, cosine is always on the axis. That's what I was meaning to point out, is that cosine here is always on the axis. When n is odd, so this number here, I just end up with 3 petals. But when n is even, I end up with twice as many petals, 2 n petals. All right, so one more time. Cosine function always starts on the polar axis. The 4 is telling you how big the petal is, right? If this was a 2, it would be a much smaller petal. And when we have an odd number here, we have exactly that number of petals. When we have an even number here, we have twice as many petals. All right, and we can just see that's because, and then the cycle is it's also taking it longer to cycle through. So that kind of makes sense, right, in terms of number of petals. All right, when I have a sine, that's when my petals are not opening on the axis, right? And again, I have the same kinds of things. 3 is how big it's coming out. If it's an odd number, I have exactly 1, 2, 3, 4, 5 petals. And if it's an even number, I have twice as many petals. All right, so we did circle and roses. We're going to look at cardinoids and limrisons, inner loop and outer loop, infinity sign, and Archimedes next week. So let's just practice these a little bit. All right, can you write an equation for these? All right, so when you're done, so pause the video, see, can I write equations for roses and circles? And then when you're ready, restart and check, and then use a different color to show if you got it or you needed help. Right, so here we have on the axis cosine. It goes up 1, 2, 3, 4, and 4. And I see 1, 2, 3, 4 petals. That's even, so I know it has to be 2 times theta. All right, here we have a circle, and the circle never has a value here, right? And it goes out 1, 2, 3. It's opening this direction, so 3's got to be positive, and it's a cosine because it's opening. And notice that the circle opening this way fits exactly with the rose opening on the polar axis. All right, now we have not opening on the polar axis. It goes out 1, 2, 3, 4, 5. So I have a 5. I see 3 petals, so I have a 3. All right, well, let's see here. We have which of the following, the graph of polar function, -4 cosine in the polar coordinate system. Right, so this you only have a choice of a circle because there's no value with the theta. And after you try, see, did you get it? Right, there's a negative, so it's opening to the left. It's on the axis, so it has to be choice D. All right, another one, we have the graph of a polar function. We have 2, r equals f of theta and r equals g of theta. It gives us r and it gives us f and g. It says which of the following is a possible polar coordinate for where f of theta equals g of theta. All right, go ahead and give it a try. I would start with a very simple sketch of these two. All right, and then see if you can get it. So restart the video when you're ready. All right, so like I said, I would start with a very simple graph, right? They're both circles. And so we have some intersecting point. mathematically, when we see two things are equal, we set them equal to each other, and we can solve this, right? And we can say, okay, 3 pi over 4 or 7 pi over 4 is where the cosine is going to equal the negative sign, but I need to think about, oh, in this quadrant, it's going to be 7 pi over 4, right? And so now I can find my answer, and I could check it as well. This is just checking your answer, but you can see that that's the right answer choice. And last one for today, the graph of the polar function is given in the polar coordinate system. Which of the following is the graph or the function for the graph that you see? When you're ready, restart the video and you can check your answer. All right, I hope you said A. We see it goes out 1, 2, 3. Ah, they're all threes. It's not on the polar axis, so it can't be C and can't be D. And then I need to remember, if I see an even number of petals, I have to do 2 times n to find the graph. All right, so good practice for today. Upload your practice, and I'll see you next week.